So, good morning. My name is Rajiv. So, I am fine. We'll come to the point. So, once again, I'm repeating myself. My name is Rajiv. So, I would like to explain Ansys software from the scratch to end. So, from Ansys software, we can learn many things in terms of simulating the particular product. So, directly I'll jump into the software. The theoretical stuff I'll post it on another video, so keep that one in apart. Now I'm sharing my screen. So you can install any version of Ansys, but that could be in above 17 version. So you can click start and type Workbench, or else you can access in the way of click all programs. I've installed 19.2, so I'm clicking 19.2 here. So drop down, drag down continuously, and at last we could see Workbench 19.2. So you can pinch on there so that it will open the 19.2 version of Ansys. Workbench window will open. It is loading all sort of analysis part in terms of license pay. I hope so. You are seeing my screen, Workbench screen. So once you open the Ansys Workbench, you could see the first left side is toolbox, because since it is colorful, so your eye would be moving on over there. Then second is blank page, and third is on the top. So what you have to see on here is, first of all, look at the top menu bars. So these are all menu bars, we can say. So file menu bar, view menu bar, tool menu bar, units menu bar, extension, jobs and help. So speaking about this individually, we have a segments. So the first segment is a generalized segment. How we create a new project. How do we open the existing project in terms of .wppg, workbench project files. So you can save also in terms of .wppg, and save as could be in another format. So the second segment would be dealing with purely online based. So this part is not much essential for the freelancers or a person who are in the learning purpose. A person who's working for the peculiar industry, they'll be using this much. So the third segment is about you can import your files in terms of other cases like geometrical formats or some other software file format extensions. So like a Workbench project archive files, Workbench Revise 10/11 project means .wp db, Workbench database file format, then Aqua database file format, and .ad. Likewise, a lot of formats are available. So if you worked on any CAD packages, so you can use this geometric file format in terms of .sat, IGS, or whatever you want. You can pick this and you can import it. Or else, apart from the CAD packages, if you work for anything like analysis software, and particularly modeling part. So you can import through other fashions. Okay. So coming to the archive, so you can compress your files in terms of shorter memories. See, when you are working for a particular project, it will take or it will consume more memories in the temporary folder. In order to avoid that, you can use archive so that it will be reduced. Let me say for an example, so 3 GB file, if you are working in the project base, so once you click the archive, it turned to 1.5 GB. So 3 GB is turned to 1.5 GB. That is what the purpose of archive. Maybe you can use this restore archive option to regain the original files, I mean expanded after expanding. So then scripting. So scripting is nothing but you can run your project file in terms of journal file format or else python script file format in terms of .py. Fine. So you can export your report also, I mean workbench this complete report with the help of this. And the last before segment is nothing but recent work files, recent folders. And exit is nothing but closing this workbench window. Second is view bar. So here you can refresh your project, whatever you are playing in the project schematic. Second is compact mode. Compact mode explains you that you can minimize your workbench window in the not generalized screen bar. So I'll show you. Look at here. Once you click the compact mode, look at here. You could not see the workbench in the taskbar, but probably you can see in here. When you move your cursor button on here, so it will comes. So want to restore in the previous view, so you can click the download button so that it will works properly. Then the second segment is about resetting the workspace and resetting the Windows layout. Reset the window workspace is nothing but once you're closing this toolbox, project schematic, you don't know how to regain it. Even if you are right clicking, it is not open. You can go to the view and click the reset workspace so that it will come all the thing in a proper location. So reset the Windows layout is nothing but minimizing your windows or maximizing the windows. So this third segment is dealing with your toolbox. So this toolbox, what it is telling so since it is having a tick mark, so it is replicated on the left side. So project schematic, it is on the right side. If you click toolbox customization, so this customization would be expands. Look at here. After I got a tick mark, so it is expanded here. So here you could see all the physics of your analysis. So the design assessment is a customizable physics. You can add multiple physics into this case. And eigenvalue buckling is a structural physics and falls under the solver type as mechanical APDL. See, as you might be heard of this mechanical APDL, since that is also available on here. So in the start, if you type APDL, it will works. Okay. So mechanical APDL is a solver type. So you are buckling problems using the equations from the mechanical APDL. So mechanical APDL means mechanical Ansys program development language. So this analysis type is nothing but eigenvalue buckling. Similarly, you have a lot of physics here. So the green color indicates your structural physics and your blue color indicates your fluid physics. So red color indicates thermal physics. So somewhat the purple color indicates the multiple physics and the vibrational physics. So apart from that, if any color you could see like orange or the combinations of orange with some red, so that is magnetic and electrical application. Fine. So similarly, this is what the first segment of your customization toolbox. So that is analysis. Okay. I hope so you understood about this case. So whatever you enable in the checkbox, that is replicated on the analysis system. For example, if I'm enabling the eigenvalue buckling sums up, so that is replicated in the analysis system. If you disable it, it won't be replicated. So whatever thing which I know very well, so those things I just mentioned on the left side through this enabling of this box. So next come to the part of components. So components having the subsystem of your original analysis system. For example, if fluid flow having a multiple options like pre-processing, solver, and post-processing. So those individual steps can be carried out on here. For example, let me double click it so that you could be replicated in the project schematic window. So geometry you could see that is what the first procedure of your analysis. Second is meshing. Third is setup of the problem. Then solution you could see, and at last you could see the results. So here, these are all individually, if you want to work for this, that is called your component systems. Okay. Look at here, the geometry is replicated on here. So meshing is replicated on here. So setup is replicated on directly connected to the window of Fluent. So solution, it is also falls under the same Fluent. So results or will be seeing on CFX or CFD post processing or results here. Okay. So what I'm trying to convey is the individual working of your analysis is nothing but your component systems. Got it? So next is I'm closing this. Look at here. So toolbar customization is over. Still few more things is available. That is custom systems here. So by default, FSI interaction is available. That is fluid structure interaction is available. So once you double click, it will be directly connected to the structural physics. See, fluent and structural physics is replicated here. So it is loading and it comes on here. The same geometry. The geometry is same. The output of the fluid will be the input for the structural. Means that you can consider an example like take one water is coming out from the pipe. So the pipe outlet uh, based on the diameter of the pipe. So your mass flow will be maximum or minimum that we could check it up, right? So that mass flow will be impacting to the any structure, how the structure will be breaks. So if you want to find out such a kind of interaction, so this FSI would be help you. So fluid output will be the input for the structure. So structure, how much it is getting the deformation or stresses and all. So that is what the fluid structure interactions. Or else, if you want to focus on some other part like vibration or uh, thermal, so you can add those things also. How? Look at here. So I would like to add the model physics up to the solution part. So I can add, means that for the particular product you can do fluid analysis, structural analysis, and vibration analysis. So similarly you can add the thermal physics also for here, or else you can add the solution up to here also. It is probably fine. So this is how also the link would be connected. So similarly, if you want to add multiple physics for your particular product, you can do. It is not that much complicated. Fine. So now, if you want to name it for your own fashion, you can double click here. You can name it. So it is a fluid analysis. Analysis. Similarly, here you can type structural analysis likewise. And also there is another flexibility also available. You can right click and you can delete it if you don't like. I don't want to use for separate geometry, I mean same geometry for the another transient. So you can delete the geometry and you can shoot for only the solution steps. Even if you don't like this, you can delete it. It is not that much complicated. Even here also you can right click and delete the connections. Means that only up to here it will be taking the reasonable boundary conditions. Okay. So maybe if you don't like anything on here, you can click on this part and delete it so that it will be deleted. Clear? Or else if you click this new project, means that you can save it or you don't want to save it. Now, as of now, for time being, I'm not going to save it. So click no so that it will be comes in a new window. So we seen custom system, then design explorations. So this design exploration will be help you for optimizing your designs. So for fixing the proper size and shapes, by the way, the shape carrying the stress and the strains. So through the parameterization method, we can uh, benchmark it easily. So this design exploration also will be covered in the future part. So for forthcoming videos will cover the part of these things, including the Six Sigma analysis. So I hope so you understood about this part. So files, so what are the files you are working that will be replicated on here. If you don't like, you can close it. Similarly, you can check out the outline properties of the individual analysis as well as the property of the individual analysis. Let me first close these two things and I will show you how it is working. So you just double click the structural physics. So look at here. So you can directly click the property window or else you can right click the geometry and click the property window so that it will be displaying the geometrical property windows. So look at here, solid bodies, surface body, line bodies, parameterization, parameter key, attribute. These are all the basic geometrical options and advanced geometry options also defining on here. Whether you are solving your problem in a 2D method or 3D method. So you can use these advanced options. After picking the geometry to set all these things, it will be work it out. So for the model window, it is different. Different property window would comes. And for the setup, it is a different property window. And for the solution, it is a different property window. And for the results, it is a different property window. So anyhow, when I'm talking about the individual analysis part, I will be explaining you all these things. Even for the uh, uh, in this video, we are learning only the interface of how this workbench window is look like. Clear? I hope so it is clear. So now you can close this, means that you can delete it. So next is the license preference. If you are preferring the license for uh, only the mechanical enterprise or mechanical premium or Ansys Polyflow or Ansys CFD or Ansys Fluent, you can pinch it. So if you are using, you can use one, or if you don't use, you can put 0 and click OK. Now, since it is a cracked version I'm using, so the license is commonly patched available. So nothing to worry about here. So next is option wise. In this option, you could learn a lot of things to manage your customization, customizable stuffs. So project management is nothing but where you are going to save your files defaultly, and temporary files where it will be loaded, where it will be saved. So the archive things is .wppz. So that is 3 level it will be considered. 3 times it will be taking the compression. Means that 9 is the maximum level, but 3 is the minimum level as it defined by the default. So appearance, if you want to change the coloring style, you can change it. As well as if you want to see the rest of things, the text colors, Ansys logo, edge thickness, for detecting the free edges, single edges, double edges, triple edges, multiple edges on a single line in meshed way. So you can change the colorings as your wish. Similarly, you can check out the regional and languages options. So only 3 options are available as of now. Mostly people used to follow English and graphical interaction. So some people will be interested on uh, the customization of how you are controlling your CAD packages the same way you are expecting in the CAE ways also. For example, CATIA software is available. So CATIA, what they are doing now, they are having a flexible movements in the mouse and keyboards. If you want the same thing, you can adjust those assignment on here. That is a graphics interactions or graphical user interface interactions. Okay, all the things are there. You can check it out. Similarly, journal files, Means that once you record the file, next time you don't want to do all the steps one by one. You can directly import this general file so that it will be automatically read all the things. And project reporting, it's just reporting after you open the default browsers. And solution process, so even if you are minimizing your window, whether it is working or not, so such a kind of things you can check it up on here. So extensions, this part I'll come to the part after I'm enabling here something. So mechanical APDL is also available. Usually it is taking 1 GB of memory and workspace is about 2 GB, and there are two processor we have. And also you can improvise your system speed in terms of go to the run command and type msc configuration, ms config. You can type msconfig and enter it. So usually in the board bar, so in the advanced options, mostly people are not setting four processors, since my lab is having a quad core processor, so that it is showing four. If you are dual core, so only two core will be available. So make sure that always giving the four as a processor, so that you can give the work to all the processor, so that the CPU can completely work. If you use only two processor, only the 10 or 20% of CPU can be workable. And also the maximum memory 0 is by default available. You can deselect and enable it. So complete 8 GB memory is usable now. Click OK and apply and click OK once again. So exit without a restart means that those processor will be consumed on here. Even for the APDL, so I want four processors needs to be worked, not only the two processors working. Similarly, if you attach it with any other external graphics, you can check it up, as well as the graphics processing unit accelerator. If you want, you can set it up here also. So by default, I'm having here Intel graphics card. So I don't have any NVIDIA or AMD graphics accelerator. So I'm using the Intel stuffs. So you can set it and then you can use CFX. This is only for the CFX options. And design exploration options also available for the design of experiments, response surface, sampling optimization. Maybe when I'm working with CFX kind of cross processing, so I can deal with these options. And for when I'm coming to this part, I mean, uh, or you can say this design exploration part, I'll explain you that time about this cases. I mean, there's enough my experiments, response surface, sampling and options, sorry, optimizations. So speaking about the repository, it always used for checking the updates, that's it. And for fluent options, you can set it. This is for CFD application. Similarly, for mechanical, you can set whatever you would like. And for meshing window, you can set. And engineering data, material properties, you can set it. And for Excel sheet, you can set it. For turbo systems, you can set it. And last is very important, that is geometrical import. Once the geometrical import, after 17.0 versions, so your default geometry is space claim design modeler. So how do you change that one? No. So click the preferable geometry editor from Faceclaim Direct Modeler to Design Modeler. Mostly Design Modeler is a thing which flexibly you can do the computational cleanups. Okay, but for creating a body, Spaceclaim will be better. Only within one or two options you can prepare. You can completely define the geometry paka. As well, all the CAD licensing is released. Similarly, you can check out the other options and we can set it. Use always stitching the surface while importing and clear the geometries on importing. So now don't click the restore or default so that everything will be gone off. Now click OK. So all the options are set properly as of our knowledge in the Workbench Interface tutorial learnings. So next is unit system. Under the unit system, you can see all the unit system like SI, metric, and US. So don't think about FTF system, CJ system and all. Maybe if you want to look up such a kind of things. So what you do is go to the normal display values as defined and unit system here. In the unit system here, you can see all the things SI systems. So here's consistent CGS systems, NMM systems, micrometer kilogram second systems, bin systems, BFT systems, then FPS systems also available. So feed degrees in the design model, and similarly here you can set it. Mostly people are working on SI system. Maybe if you want to import your own systems, so you need to prepare in terms of .xml file format. Click import. So look at the .xml. So whatever you created through the Excel sheet or Notepad, you need to export in terms of .xml so that we can import it on here. So this is what we have in the unit system. Next is extensions. So if you would like to see your SolidWorks or CATIA workbench on here, so you can use here install extensions in terms of maybe CATIA. You can download a CATIA and you can click that extension for Ansys compatibility and you can install it or directly open it. Similarly, you can check out other things also. So jobs, whatever the jobs you are doing, that is defining will be on here. So there are two ways to see your job monitor. One is on here, another thing is on here. I'm clicking the job monitor. Look at here, what job is working and what is the status, how we are submitting, and who is the owner, and what are about the rest of things. High power computing configurations, high power computing in the QA. So these are all little deeper look. So these things will be discussed on further videos. So help tutorials are available in the Ansys Workbench help. So that make sure that before clicking this, switch on the internet so that this thing will be working, or else separately you install the Workbench help tutorials. Fine. So now I'm end up this video now, since this video is fully dealing with Workbench interface, just Workbench interface. That's it. Fine. So thank you, gentlemen. Can use file and exit.